Okay, dear grade 8 students, here we go with the second training exercise. Draw a right triangle ABC, right angled at A, such that AB measures 5 and AC measures 4. So, we draw a right triangle ABC, right angled at A. Of course, we use the ruler. That's measuring 5 and that's measuring 4. Mark E and D, the midpoints of AB and AC respectively. So I need to mark the midpoints of AB and AC respectively. That word respectively means that the midpoint E is for AB and the midpoint D is for AC. That's what we mean by respectively. So E is for AB and D is for AC. So because AB is 5, then the midpoint of AB must be at 2.5. Okay, because the half of 5 is 2.5. Because AC is 4, then the midpoint of AC must be at 2. So that's how to mark a midpoint. So here are the midpoints, E and D. Okay? Construct the circles C of center E. So I have to put the needle of the compass at E and radius 2.5 and another circle C prime of center D and radius 2. So that's the first circle of center E and radius 2.5. As you see, that's the center. The distance from the center to any point on the circle is 1, 2, and that's the half. Okay, that's the half, then 1, then 2. That's the circle of center E and radius 2.5. And C prime is of center D, so we put the needle of the compass at D and we draw the circle of center D and radius 2. Now draw a circle C double prime. So the name of the second or the third circle is C double prime, but it is of diameter DC. What do you mean by diameter DC? If I need to draw a circle of diameter DC, the measurement of that diameter is 2. But to draw a circle, we don't need the diameter, we need the radius. To draw a circle, we need the radius, and the radius is the diameter divided by 2. So the radius is going to be 1. So I'm going to draw a circle whose radius is 1 and whose center is, of course, the midpoint of the diameter DC. So the radius of the circle C double prime is 1 and its center is the midpoint of DC. So here we go with our tiny circle of center whose midpoint of DC and whose radius is just 1, which is half the diameter DC, which measures 2. Now let's specify the relative positions between these circles and pair, each 2 together. Okay, so 2 by 2, that's what we mean by impair. First of all, let me join the centers because we care about the centers. So I joined the centers E, D, E, and K, and D and K are already joined. According to C and C prime, so according to the purple one and the red one, it's clear that they are intersecting, and here are the intersection points. So here are the intersection points. Here is the first one, and here is the second one. So C and C prime are intersecting. Notice that the distance between their centers, which is the distance ED, is measured 3.2. I just measured it before preparing, while preparing this exercise, and the measure of ED is 3.2. Okay, we can use the ruler and measure it. That 3.2 is exactly between the difference of the radii. What's the difference of the radii? The bigger radius is 2.5. The smaller radius is 2. Their difference is exactly 0.5. And the sum of the radii, one of them is 2.5 the other is 2, then the sum is 4.5. So we notice that number 3.2, when I measure it with the ruler, is between 0.5 and 4.5. And that's the property that you should memorize, that whenever we have intersecting circles, the distance between the centers is bounded between the difference between the radii. Of course, we put the bigger radius before the smaller one, and it's bounded also between the difference between the radii and the sum of the radii. Okay? Now, according to C and C double prime, so the purple one and the blue one, notice the purple and the blue, they are externally disjoint. There is a space in between them. The distance from the center E to the center K of the smaller circle is greater than the sum of the radii. Notice that the distance is 3.91. And also, I just prepared it while preparing this exercise. I measured the distance from E to K and it is 3.91. Again, you can use the ruler to measure the distance, and you will notice that distance is greater than the sum of the radii. The radius here is 1. The radius here for the purple circle, the radius is 2.5. The sum is 3.5, while 3.91 is greater than 3.5. So the distance from E to K between the centers is greater than the sum of the radii, which is 3.5. That's the justification. Now, according to C prime and C double prime, so according to the red and the blue circles, I can notice that they are internally tangent. Notice they are internally tangent. The radius for the bigger one is 2. The radius for the smaller one is 1. If I subtract them, my answer is 1. And that's exactly the distance between the centers. So they are internally tangent circles. And the justification is because the center between the radii, we can say dk or kd, whatever, is exactly equal to r double prime minus r prime. Okay, r double prime is for the circle C double prime. So sorry, we should write the distance between them is the bigger one, which is r prime minus r double prime. That distance, which is 2 minus 1, is equal to 1, which is exactly equal to the distance between the centers. Okay? And here, the distance is greater than r plus, we have to write r double prime. I guess I said r prime, it is r double prime as well, because whenever I say the circle C double prime, I have to say the radius is r double prime. If the circle is C prime, then the radius is r prime. So, to recall, for C, the radius is r. For C prime, the radius is said to be r prime. And for C double prime, as you see, the radius is said to be r double prime. So here we have to say it's greater than r plus r double prime. And here we say that the bigger one, which is r prime minus r double prime. That's the difference between the radii, and it's exactly equal to the distance between the centers, and thus the circles are said to be internally tangent. It's clear that they are internally tangent. Now specify the relative positions between the circles in pair is done. Now if I want to answer these questions, what does AB represent for C prime? If you look at the line AB and the circle, the red circle C prime. So if I draw the line AB, that black line, what is it according to the circle C prime? It's a tangent. Why? Let's make sure of the angle. If I move the angle DAE, I can notice that the angle is measuring 90 degrees. So that line is perpendicular to the radius or the diameter of the circle C prime. So we say that that line AB is tangent for C prime. What about AB and C double prime? The blue circle is C double prime. The line AB is definitely exterior to that circle C double prime. So let me close this, okay. That line AB and C double prime, that line is external line to C double prime. What does BC represent for C? Let's draw C again. What does BC, the line BC, let me join it. The line BC is, according to C, it is a secant because it's cutting it at 2 points. This point B here and this point. Okay? So let's review them. AB, as I told you, there is a 90 degrees, is tangent to circle C prime because it's perpendicular to its diameter or its radius dA. Whatever, diameter or radius are the same. AB, that line, is according to that blue circle. So let me hide this. AB is according to C double prime, an external line. It doesn't intersect it at any point. And let me redraw them. BC, that line BC, according to C, to the purple circle, is a secant because it cuts it at 2 points, as well as it's a secant for C prime too. Okay? That's according to the relative positions between. So that line BC is a secant for the purple circle, the red circle, and the blue circle as well. It cuts each circle at 2 distinct points. So that's according to the relative positions between circles together and circles and lines. Hope you enjoyed these training exercises, and we will meet inshallah in more videos in other chapters.